Right, let's see first the VLAN related labs. I'm going to take two switches and I'll connect some computers down here. And we are going to have a trunk in between these two switches, so I'm going to have one link. We will also see ether channel in the same topology, so I'm going to have two links. 03 and 04 are going to be trunk link. Right. As of now, our aim is not to understand ether channel. We are going to focus only on VLANs and switch port modes, and then we want to capture some packets and see how it look like. In packet tracer, you can capture packets like this. See, it shows the packet. You can click and see each packet, how it looks like. You see, it's layer 2, and it shows the MAC address. It's a BPDU packet. It's a BPDU packet. Okay, so this is also a way to capture a packet and see. Now let me stop. I'll give an IP address to this 10.0.0.1 and I'll put 10.0.0.2 for 10.0.0.3 and 10.0.0.4. Right, as of now, all are in same VLAN. We all know that by default, all ports are part of one single VLAN, and that VLAN number is 1. Each VLAN is a broadcast domain. Now, when you combine two switches like this, what actually happens is the broadcast domain gets extended. Can you tell me how many broadcast domain we will have in this topology? Very good. That is what I want. You see, this port is also VLAN 1. This port is also VLAN 1. And when you combine these two switch, it is going to merge a single broadcast domain. So adding more switches will not add broadcast domain. Though we used to say one switch is one broadcast domain, but when you connect switch to another switch, they become part of that same broadcast domain called VLAN 1. As a result, I'll be able to ping from here. First, let me give IP address. There is no need for gateway because I don't do routing now. I don't do routing. All right, and last. Now, if you try pinging, you can ping anyone because all are in single broadcast domain. It's in single broadcast domain. Now, it is not wise to have a single large broadcast domain. It's not correct. It is not good for the real world network. Why? More larger the broadcast domain is, more congestion. Yeah, because every now and then some PCs will be sending some broadcast traffic like ARP, DHCP. This all uses broadcast, layer 2 broadcast. So let's see whether we can show you some. What packet is this? Again, HTTP BPDU. This is layer 1 and layer 2 information. I'm trying to find an ARP packet. Filter. Only ARP. And DHCP. No problem, DHCP. This is not. I'm going to clear. Okay, I have only one MAC address. Let me try pinging. And I should see some ARP ping. Let me try playing here. Okay, playing here. Ping 10.0.0.3. Hmm. I can see the packet going slowly. See, it's not going here, but it will be received here. Okay, there's an ARP reply going. Super. Very nicely shows. Then now it will go to 10.0.0.1. It was showing very nicely the broadcast. See, this is an ARP reply. You see, ARP reply. Now let us try to find the ARP response. So the ARP request. ARP request will be sent to a broadcast address. This is response 10.0.0.1 was sending ARP. Oh, come on. It's not allowing me to click. Stop. Now I can click. Okay. Yeah, this is it. You see all F's. This is all F. Source address is this PC's MAC address. See, ending with 9BA. Let's go check it here. 9BAA. ipconfig/all. See, 9BA. So this is the PC whose 10.0.0.1 IP address is sending an ARP request. Okay, what we are trying to understand is every now and then there will be some broadcast happening, which will be going to everyone. And you saw that not everyone can use the packet because ARP request is for one particular destination, one particular computer. But all the other computers also process the packet and they drop. You saw some X mark here saying, this is not for me, this is not for me. These PCs were not accepting the our packet because the packet was not for these other PCs. It's only for 10.0.0.3. So when you have big broadcast domain, this type of unwanted packets, unintended traffics come to everyone very often, which will consume the bandwidth, CPU cycle, etc. This need to be reduced so that our speed of the network can be improved. Yeah, creating VLANs will improve the bandwidth. How? When you create VLAN and put small groups, the broadcast that happens will be within the group. It won't go and disturb the whole office, whole network. That's why we create VLANs. So we are going to configure VLAN on this switch, two VLAN, one for this PC and another for this PC. I'll say VLAN 10 for this and VLAN 20 for this. Similarly, VLAN 10 here, 20 here. Let me do that. Creating VLAN is very straightforward, simple command. We need to go to global configuration mode. And then type VLAN 10. VLAN 10. I would like to name it as sales. Another VLAN 20, name production, exit. Show VLAN brief. We can see here two VLANs already created by us, but no ports. I'm going to take this one from the default. I told you by default all ports are member of single VLAN. That's why we call it a single broadcast domain. But I'm going to put this port to this VLAN and this port to another VLAN, the production VLAN. By doing so, we will have three broadcast domains. Interface F0/1, switch port, mode, access. What does this command do? This command will administratively change the port mode from auto to access. Let me show you before I hit enter. I would like to show you this. Show interface F0/1 switch port. You can see here by default the administrative mode is auto. You see, when I put this command, it shows the administrative mode is auto, meaning what? This port can become a trunk also if someone negotiates. When no one negotiates, it is operating as a access port. Don't get confused with the word static and all. It is not statically configured. They are just calling like that. But it is operational mode is access. It is not trunking. Administratively, when it is auto, operationally it will be access as long as no one negotiates trunk with this port. So what is next? I'm going to make it as access permanently, hard code it as access, because I know this port belongs to single VLAN. Switch port mode access. After putting this, let me take you back to the same command. Now you can see administratively it is static access, so operationally it will always be access. Even if someone negotiates, this will not switch to trunk. Yeah. So making it as switch port mode access, administrative mode as access is recommended so that no one will remove the PC here and connect a switch and form a trunk here. Better put the mode as access on all the host connecting ports. Okay, it is an access now. What is next is I need to assign this to a VLAN. Which VLAN? VLAN 10 sales. Switch port access VLAN 10. Likewise, interface F0/2 switch port mode access switch port access VLAN 20. So now we have one port in production, one port in sales. Show VLAN brief. You can see it. Now I'm going to create same VLAN on the other switch. First VLAN. So creating VLAN, we have seen me going to a global configuration mode. This is another way. You can go straight to the interface. This interface. I'm going straight to the interface. And I say switchboard mode access. I've not created VLAN so far, but I can create like this switchboard access VLAN 10. So when I say this, automatically VLAN 10 gets created. You see, it says that the VLAN doesn't exist, that access VLAN does not exist, but creating, it has created for me. The difference is you will not have a name option to give a name. You will find VLAN, but some random name, show VLAN brief. VLAN 10 is created and it has given randomly, not randomly exactly, it is like this. VLAN followed by 4 numbers in which, whatever the number that you configured as VLAN will be there. Because 1005 is the maximum number of VLAN that this switch will support. So there is 4 digit. Now I'm going to create another VLAN, assign this. This time I would like to go to VLAN 10 and name it sales. Okay. Now interface F0/2 switchboard mode access switchboard access VLAN 20. Now let's verify. Show VLAN brief. We can see sales and production. Now, will the ping happen between these 4 devices? Can any of this device ping the other 3? No. But can this ping this one at least? This also in VLAN 10, this also in VLAN 10. Can these 2 ping? Cannot ping, right? Likewise, this also cannot ping. Why? Because we don't have a trunk link here. Correct? We want a trunk link which can carry VLAN 10 and 20 traffic. Right now, this is in VLAN 10. This is in VLAN 20. VLAN 10, VLAN 20. But these links between these 2 switches is not a trunk. They belong to VLAN 1, different broadcast domain. So, as a result, when I try pinging now from here, 10003, though it is 10003 is in same VLAN 10, the ping won't happen. Okay, so our job is to make this ping happen. For that, I'm going to make this link trunk. These 2, correct. By default, all ports on the Cisco router will be dynamic auto. Now, let me show you that. What you asked is a good question. Let me show you that. These are the two ports which are connecting between these two switches. So when I type show interface F0/3 switch port, I can see dynamic auto. Also on 04, it is dynamic auto. Now I'm going to make this two as trunk switch port. Sorry, interface range F0/3-4 switchboard mode trunk. So this will change the administrative mode on both this port from auto to trunk. So we are turning on the trunk here. Understand? This is going to trunk, but not because someone negotiating. It is because I turn it on. This is what called as on mode. Trunk on mode. What is trunk on mode? Trunk is turned on. It is not going to trunk because of negotiation. You see, I turned on the trunk. Let me show you. You see, I have put the administrative mode as on trunk. This is what called as on. You can also see that one more interface. Let me show you. Then I'll show you the command. You can also see that on the other interface. 4. Now I want to show you that this is on. How I'll show you? Show interface trunk. You see, it's in on mode. It is trunking because we have turned on these two ports, F03 and F04. If you type this command to show VLAN brief, you can see F03 and 4 is missing. You don't see F03 and F04 because they are not under any particular VLAN now. Now they are member of all active VLANs. Trunk ports are member of all VLANs, so you cannot see that in particular VLAN. Now when I type this show interface trunk again, you can see these ports are going to carry the currently available VLANs. But if you will create more VLANs between this range, even those VLAN traffics will be also allowed. Here we see, because spanning tree will block one port and only uses the other port to prevent loop. You see none on this port because it is subjected to spanning tree. But actually, all VLANs are allowed on port. This is only with respect to spanning tree. Now, I would like to show you the difference between this on mode and negotiated mode. On the next switch, if you go and check the same command, before that, show VLAN brief. We did not configure trunk here, but it is already a trunk. 3 and 4 are already trunk. It is missing from here. How? Negotiation. Show interface trunk. You can see the default mode is auto and it is not changed. This is also trunking, but the difference is this. N means negotiation. This is trunking because of negotiation, whereas the other switch is not showing N here. We turned on, so it's not showing N. Whereas here, it is auto, but it is trunking now because of switch A negotiating with this switch B. Now I want to show you the difference in the interface level. Show interface F0/3 switchboard. You can see here it is auto only. This is switch B. In switch B, we did not configure trunk. It is dynamic auto, but it is operationally trunking because of .1Q negotiation. Now let's go to the other switch where we turned on. Show interface F0/3 switchboard. Here if you see administratively also it is trunk. Operationally also trunk. Administratively trunk because I turned on by configuring switchboard mode trunk. So the difference you will see even here, show interface trunk, it is more clear here. It's on, not negotiation, whereas on the other switch, show interface trunk, it is auto, but trunking how through negotiation. Will I be able to ping from this 10001 to 10003? Yes. Let's try. See, you're able to ping. Now I want to capture the packet and show you the tagged. That is what you were willing to see. List. Let me try pinging again. Okay, I think I have to hit enter to see the next or play. What it is doing. I said to ping from here, right? Okay. Switch one. No, it's BPT. Why it is showing me this? Stop. There is some way to do this. Yeah, this is. Oh no. So let me try again. Ping between this and this. Okay. It shows ICMP successful, but can I open this? I don't know why only it shows this BPDFs. I'm looking for .1Q. No dot. Okay, this is a packet going from switch 1, sorry, PC1 to PC3, I believe, 0537. 0537. IP config. Yeah, 0537. So that is right one. It's an ICMP packet going. We can see that, but I want to show you. Oh, look at this .1Q header. But we couldn't see the header clearly. Outage port is a trunk port and the incoming VLAN number is allowed. We couldn't see the inner side of the packet, but it explains it. Oh, look at this. It's there. It's here. Super. It's here. This is what you were asking for in that, what is that? Wireshark, right? See, this is the destination. This is incoming. So let's see outbound. Okay, this is the source. We know this 9BAA is from 10001. Going to 10003 and wait, header start one key, correct. This is the VLAN number 10. A. Yeah, that's right. VLAN number 10 is A. Right, so it's in hexadecimal. It shows in hexadecimal. Okay, so what we have seen is we were able to ping from this to this, which is in same VLAN, but I will not be able to ping the very next PC because it is in different VLAN. So this proves that logically they belong to different group. Even though the network is same, even though they belong to same switch, they don't really belong to same broadcast domain. They don't belong to same virtual switch. This is in VLAN 10 and this is in VLAN 20. So if I want to ping, I can only ping from here to 10004. I'm able to ping. Now let's try to sniff the packet. Okay, I'm pinging from 10002 to 10004. So that's what I want to see here. This is an ICMP packet. Source IP. This is all perfect. Looking good. It's going from computer, so you won't find any tag. Perfect. You see 1, 4, 1, 4 is 20. How? A is 10. Paint. So when you say 10, you say 8 plus 2. But when you say 20, it is 16 plus 4. This is 20. Now, 4-bit of binary is 1 bit of hexa. You know how? Do you know how 4-bit of binary is 1 bit of hexa? Sorry? You don't know. You see, what is the biggest number in hexa? You are not clear. What you are saying? F is the biggest number, right? How do you write in binary? 1111, correct? Now you see 1 bit of hexa. To write that 1 bit, how many bits you need? 4-bit, correct? Now you understood this 1 bit of hexa is 4-bit of binary? Okay. So what we do is we take this separately and then this separately because in hexa we need to write. So what is the value of this one? 1. What is the value of this one? 4. So 20 in decimal, 20 in decimal is 14. Do you agree? That is what we saw here. You see 14. So it's the .1q tag. This is what it inserts, the .1q inserts before sending out via the trunk port. Okay. Now, in the real world, we will not put same subnet in different VLAN. Why? We will discuss. You see, this is VLAN 10, VLAN 20, VLAN 10, VLAN 20. Now these two, one broadcast domain, these two are another broadcast domain. And if you want A to ping B, if you want A to ping B, you have to go from one broadcast domain to another broadcast domain. Only a router Only a router can help you communicate between two different broadcast domains. Only a router. So let's take a router. If I want to connect between two different VLAN, I need a router because router, each port is a broadcast domain. So I can give this port to VLAN 10 and this port to VLAN 20. For example, this port is VLAN 10, VLAN 20. See, on the router you cannot assign VLANs, but you can connect this F0 of the router to VLAN 10 here and F01 to VLAN 20. By doing so, traffic can go like this and get routed and come down here. But if you want this to happen, this port and this port should be in different network. You cannot have 10, 0, 0, 10, and here also some 10, not possible. Every port of a router must be assigned to different VLAN. Sorry, we a different subnet. So let's say I want to use 10 on F01. I cannot use the same 10 and I want to use 20, 20, 0, 0, 10. Then all this PC that is in VLAN 20 should be in 20. I'm trying to explain you the reason why each VLAN should be in different network. If only it is in different network, inter-VLAN routing is possible because router needs different network in each port. Right? So we need to provide different network address for each VLAN. VLAN 10 and VLAN 20 cannot be in same 10 subnet if you are planning to do inter-VLAN routing. See, if your aim is to just simply separate in multiple groups, then you no need to put in different network. But if any time you want to ping from A to B, ping won't happen even if you have a router if they are in the same network. In order to have reachability between the devices of different VLAN, you need to put each VLAN in different network. Is it understood? Hmm. Correct. Correct. Cannot ping because two different VLANs. Yeah. Hmm. VLANs. Hmm. Hmm. network. Yeah, because correct, subnet also. Okay. You see, the routers are to connect different network. Routers will not allow, is not meant for forwarding the packet between the same network. Not possible. Routers are not meant to forward the traffic within the same network. It is to forward the traffic between different network. So if you wish router to forward the traffic from VLAN 10 to VLAN 20, then we need to make sure they're all in different network. Each port in the router has got a broadcast domain. So for VLAN 10 and VLAN 20, you put different network, not the same. So if we want this ping to happen, we must change this to 20 and this to 20. Each VLAN should be in different network. Twenty. So now we have just changed the IP address. This is to tell that each VLAN must be a member of different network. Now, if you want to do inter-VLAN routing, you need a router. I bring a router and I'm going to connect two wires. This is going to be VLAN 10.05. Another one I can connect here or on the same switch. I'm connecting here. This is going to be in VLAN 20. This is not practically done in the real world. I'm just for understanding. I'm taking a separate port for each VLAN, which is not practically seen in the real world. We'll do something called router on a stick in the real world, which we'll do in the next class. But as of now, let's try understanding this way. So on switch 105, I'm going to assign it in VLAN 10. Switch port mode access. Switch port access VLAN 10. And on the other switch, switch port mode access 20. Okay, this side 20, that side 10. Let me bring this router up, means the ports up. What is the interface name? G000. And I'll give an IP address 10.00.10. This should be given as a gateway to the computers. Done. This should be assigned as the gateway to the PCs, right? So I'll go to this computer 20 and put 200010 here. And in this gateway should be 1000. And this PC, and in the last PC, done. Okay. So now you will be able to ping between 10001 and 20002. Let's try pinging. Ping 20002. It will go to the router and get routed and come. Let me see the routing table here. Show IP route. I have the routing table. 200010 and 100010. Why is this not pinging? I think I have not assigned this to VLAN 10. Did I? I did. Okay. It is. It is there. Let us try understanding why the ping is not happening. You see, when I ping from here to here, it will go to the gateway. And then it will route. It will send here, and then traffic will come here and come here. See, in this scenario, which I created, it should be access. You are thinking about router on a stick, which we'll be seeing in our next class. In that, I should have trunk, because there we will have sub interface. Here we are not having sub interface. This should ping. Maybe in the PCs I made some mistake. What is the gateway? 100010. Okay. It's not 20, it is 10. 200010. Okay, here I have given correctly. All right, now it should ping. It was one mistake here. I put 20. Now it will ping. You see, the ping is happening now. Let us trace route and see. Trace. You can see it goes to the gateway and then to the final destination. Likewise, when I ping from here, you can see it goes to the gateway, then it goes to the final destination. Right. So this is about VLAN, switch port access, trunk, on mode, trunk, all the stuff. Right? We have not seen dynamic desirable like access auto. We also have dynamic desirable.